Hello everyone, welcome back to Last Call BBS. We're a little bit spoiled for choice here. Back to listing. Several good games left to play. I do not want to play Hack Match. It's a match for, like, not like Tetris, but I don't know. I'm sure there's some more canonical game, but it reminds me of, like, Super Puzzle Fighter, where you're, like, you know, you're trying to move. It doesn't even really remind me of that much. That's just the game I played that's most like it. You're trying to match stuff up. I mean, we can look at it, I guess. We'll download it. In the meantime, let's boot up some Dungeons and Diagrams. What to do here? Interesting to note there's only one wall along this edge, because it means most of these skeletons, or perhaps all, will be led into this area, right? Okay, well there's 6. Yeah, these 6s are good, I guess. There's only one spot along this area that doesn't have a wall. And it can't be this one, because then it would be a dead end. Can't be this one, it would be a dead end. Can't be etc, etc, etc. Can't be this one either, right? Right. So it could be this one. Or it could be this one. And we can make the same conclusions all the way down here. Is this symmetrical, by the way? No. So now we can say this must be part of the treasure room, because the treasure room can't go all the way up there. So that's something, I guess. What about along this area? We can say some similar things about this, right? Most of this has to be wall, because there's only one non-wall space. It can't be this one or this one. Okay, now we can say the treasure room extends out at least this far. And I don't think a monster can be in the treasure room, can it? This square can't be one of the squares in the treasure room, because then thered be a monster in it. It could still be open. This could be the entry to the treasure room. That would be okay. But it can't be part of the treasure room, which means this is part of the treasure room as well. And since we know this is part of the treasure room, these two must be as well. So at least this much is part of the treasure room. Now, one of these two squares is open, because there's only room for one more wall here. That means these are both walls. And there's only room for one more wall in this entire row now. And it can't be sealing off the treasure room, because one wall wouldn't do it. So it must be it can't be the edge of the treasure room, so it must be part of the treasure room. So that's the treasure room. We don't yet know where the entrance is, I think. There's only one wall in this area. Well, it can't be here, because that would make this a problem, right? Likewise this. That can't be the wall. This could be the wall. But so could this, as far as I can tell so far. This can't be the wall either, because then this would be a dead end, right? Something similar apply here? Yeah, this can't be a wall, because then that would be a dead end. Got it. And we found the door into the treasure room. No. That has to be a wall. I just miscounted the clues. So the door is down here somewhere. Could be this or not. But we need these two to be walls. There we go. We found the door to the treasure room. We need at least one wall among these two. Well, okay, that's filled in. So exactly one wall among these two, which means this has to be filled in. Because his open space is one of these two. This can't be open. This has to be the wall. Now we get all this stuff. Ta-da! Alright, so like I promised, we're going to go look at this game, but I don't really want to play it at all. This one took me a while to find. You could import the home console version of Hackmatch, but I wanted the full arcade experience, like you were really in a Japanese game center. Not gonna lie, I was pretty blown away to find out that you could simulate a full arcade machine on a Sawayama Power Lance. I would have loved to have mentioned it in my sales pitches if I could, but of course it wasn't exactly 100% legal, and most people in the US hadn't heard of Juice or its games before either. So it was a cool thing I mostly kept to myself and my BBS friends. By the way, a cool bit of, like, I don't know, Hackmatch, this was the minigame available in Exapunks, I think. You can, I mean, it has the little Exapunks little character there, I guess. And something that I thought was kind of cool, even though I wasn't interested in it, was they actually ported it to the NES. They ported Hackmatch from Exapunks. I think to actual, like, normal NES hardware. I don't think they cheated with any modern stuff, which is kind of cool. I read in the interview that I was talking about a few videos ago that they sold 400 copies. So obviously, like, very much not financially worth it, but a cool little art project. So insert coin, yeah. So we'll go 2x video size, I guess. Oh no, but now I can't see what's happening. So if you view controls, so you can insert coin. There is some, I guess, way to play two-player, right? I don't quite know how you would do that. I think there's actually like, is there an online multiplayer mode or something? No, two-player start. I don't know. So if you do this, is it actually... Oh my god. I already lost track of how to, like... J and K are your buttons. Okay. So if you play... Yeah, okay. So here's the instructions in Japanese, of course. But when you connect 4 of the same color, they disappear like so. I don't totally know what these attack things mean. So there's somehow, like, it's a competitive, like, game, right? You're playing against someone. You're when you make matches or combos, you send them junk. And somehow when you get 2 of these, like, bombs that are the same type next to each other, then they blow up everything on your board of that with that symbol. And if you get sent these junk blocks when your opponent makes high scores, and if you clear something, then all the junk boxes next to that get flipped. So okay, sure. So obviously I'm not actually going to play two-player here, but that is a thing I can do. So you have a button to flip the top 2 in a... Ooh, I accidentally comboed. Genius. I don't know. So you do this. You try to set up, like, match. This is a combo, or this is like. There you go. I sent 5 things, and that increases my little junk countdown thingy. So I don't know if I were to. See, that just clears blocks. It doesn't actually attack my opponent at all. I don't know. So anyway, I'm clearly going to win here against Righty, who's not playing, because I put in 2-player start. But I don't really want to play this one. You can play against bots, and you don't get to see their board, but they do, like, send you attacks if you leave them alone for a while, I guess. We're going to wait a minute for the next download, and in the meantime, let's open back up Dungeons and Diagrams. The Trials of the Anointed One. Oh, well, this all has to be walls. That's easy enough. These 7, all but 1 have to be walls? Is that important somehow? I don't know. All but 1 of this has to be walls, actually. Maybe that's something. Well, okay, the treasure room can't extend into this column because there's not enough spaces to place treasure. So we know the treasure room is in these 3 columns only, which means it has to reach down at least this far. Okay, cool. So this is either the entrance to the treasure room or part of the treasure room, but it can't be a part of it because there's a monster next to it, right? You can't have a monster that's in the treasure room because there'd be no way for the player to get in. Even if you were just blocking the hallway, that would be no good. So this actually has to be the hallway into the treasure room, and this has to be the treasure room. 2 more walls has to be like that. There's 1 more wall here, which can't be this one, because that would be a problem. These are all open. That has to be the wall to avoid a 2x2. And this is our first time actually constructing a circle, so it is allowed. Okay. This guy has to be locked in. This has to be a wall for the 2x2 reasons. Nope. There you go. All right, no problem, no problem. Anointed One, you make me laugh. Nice easy start there. There's only 1 wall here, and it has to be one of these 2. So we can do all of this. This can't be a wall, or that would be a problem. This has to be a wall, or there'd be a 2x2. This has to go through. What about the treasure room? It's interesting that this goes right through the treasure. Certainly, part of this has to be the hallway. Ah. In fact, this has to be like the wall of the treasure room has to be up here somewhere, right? Because this clearly has to be the path in. It can't all be treasure room. But I don't know whether it goes left or right. I guess I do know a little bit more, though, right? Because if the hallway out of the treasure room is on the bottom, then it can't be up here, which means the 2 walls in this row are taken up by barricading the door to the treasure room. And therefore, they can't be here, which we already knew, I think, or here. Or here, because the treasure room can't reach that far, so... Wait, am I crazy? Yeah, some of this looks crazy. Try again. Slow down. So if the treasure room went all the way here, we would need this to be a wall to block it. And if the treasure room went all the way here, we would need this to be a wall to block it. But this can't be part of a wall blocking the treasure room, so this has to be open. Which means this is walled off, and we get all this stuff, right? Now this 5 only has one more open space, but I don't think I know much about it yet. Now, the treasure room cannot go all the way to the left anymore, because if it did, there would be an entrance to it here and here. So at least these 3 must be part of the treasure room. So the wall is either here... Well, it has to be here, right? Because if this were part of the treasure room, there would still be another way in. So yeah, in fact, this is the treasure room. Okay, we need another wall here for the row. That has to be a wall or this guy's blocked. There's only room for 2 walls left in this column. And this place, okay. Uh-oh. No, that's fine. Ah. The Demon Count of Gluttony. Alright. The Winding Warren. Okay, this 6 wall is important, right? There's only one open space. Can't be here or here. Wait, can it be here? No, because it would be at that end. Likewise, it can't be here. So in fact, we know all of this. There are 3 walls in this... Ah, no, this is the more important row to look at. There's only 2 walls here, and at least one of them has to be blocking this guy in, right? So we can say that those must also be blocking him in, because the open space is one of these 2. And then everything else in this row is also open. And these... Well, this one, at least, must be part of the treasure room, right? Because the treasure room certainly extends down at least this far. And since these are touching and not walled off, are they not also part of the treasure room, right? There's no way they could be part of an entryway or something stupid like that, I don't think. So in fact, this is the treasure room. I don't know where the door is yet. But this finishes that column at least. All but one of these have to be walls, I guess. Could this be the passageway out? It couldn't, right? Because it wouldn't be able to keep going straight because you were out of passageway tiles. And if it goes right, we're just going to run into a bunch of monsters. And if it goes left, well, then that's another way into the... Okay, so this is a wall. If this were open, this would also have to be open, and then there'd be 2 ways into the treasure room, which is illegal. And now we know the entrance to the treasure room can't be on this side at all, because then there'd be no... It would be a dead end, so we can do this. Wait a minute. I made a mistake already? I think it was that. That was the mistake. No? Maybe I was wrong in concluding what was going on there. So can't that work? That seems okay. Ah, and this column is done. Means we've figured out where this monster goes. We've done this row now. This can't be a passage because this would be a problem one way or another, so it's a wall. Finishes this. Ah, this guy has already been given a path, so the rest must be dead end for him. Finally found the wall there, and here, and here. Okay. So, next up, Chipwizard Professional. So this I'm kind of looking forward to. Let's read the text here first. Something different from our usual fare. This download is a professional computer-aided design program for integrated circuits. You ask, Barkeep, why the heck is this on here? I say, why not? More to the point, this software package normally costs thousands of dollars. So go ahead, give it a spin and see what the big boys do with their machines. No software protection dongle required. So this is a remake of what I believe to be the earliest, not even the earliest Zachtronics game, but before Zachtronics, when it was just like Zach making stuff, I think. Now, my introduction to Zach's games was the Codex of Alchemical Engineering, a Flash game that I played on Congregate, as I recall. I'm sure it was hosted many places, but I forget if I've ever done a video about it on the channel. Probably not, right? And I didn't finish it. It was kind of like, I don't know. Magnum Opus is the much more modern version of that kind of game. And there's not much reason to go back to the original except for historical interest. But anyway, that was my introduction to the kind of idea that there could be games that were about engineering. And there was a game that I think came before that, which I don't know how the hell to pronounce. I can't spell it. Let me look that up. Zachtronics. Okay, yeah, it's Russian, right? KOHCTPYKTOP. 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 Engineer of the People. So it was a kind of circuit design game with like the theming of being somehow some kind of Soviet state engineer. I don't quite I never like, I don't know. It was not understandable. Oh, can you just play it on his webpage now? You could if it supported Flash, but Flash is gone now. I see. Yeah, I guess it was only ever written in Flash, so the only way to play it now would be... Oh yeah, I couldn't even show you Codex of Alchemical Engineering, could I? Unless I downloaded a like standalone Flash player, which is, I guess, a thing you can do. But this is a remake of it, and it was hard. I think I beat a couple of levels, but that was it. I couldn't understand what I was supposed to do in that game. Maybe, the new coat of paint on it, and me being, I don't know, 10 years older, more, right? Maybe will maybe just 10. I don't know. More experience will help me understand how to play this damn game. Chipwizard Professional. Sure. Signal crossover. Yes. Open. So are there instructions? Connect in A to out A and in B to out B. Hint, use N-type silicon, which sits below the metal layer, to pass one signal over the other. Or under, it says, I guess. So are there actually instructions somewhere? View manual. Aha! What the hell is this? Interface overview, design elements, using transistors, using capacitors. Oh my god. Interface overview. Layout windows where you make stuff. Yes. Inputs. This is the specifications. I think I understand that. Simulator window. And the visualizer window. Sure. Fine. No problem there. Tell me about design elements. The silicon layer. There's two types, N and P. By layering one over the other, you can create a transistor, the basic building block of integrated circuits. The metal layer sits above silicon, used to route signals between and around transistors. You will need to use both layers. Vias are small vertical wires that connect the silicon layer to the metal layer. When a via is in place, signals will flow freely between the two layers. Capacitors. Placing capacitors underneath the metal layer, signals traveling through the metal can be delayed by 1 or 2 cycles instead of flowing instantly. Okay. So this all seems fine. Don't understand silicon yet, but fortunately, there's this whole thing about transistors. Creating NPN transistors. Oh yeah, I remember this whole, like, it was so impossible to discover that you were supposed to click on something to make like some kind of bridge or whatever it is. Create an NPN transistor, draw a line of blue silicon, and cross the middle of it with a line of red silicon. Signals can only flow between the two blue terminals when there's also a signal entering the red gate that controls the transistor. Okay. To create a PNP, you do the opposite, right? So that's when the P is the control, it only, okay, hang on. They only allow signals to flow between the two red terminals when the N type is not powered. So like, when red is a control, on means go. When blue is a control, on means stop. How could you, what would be a mnemonic for that? I don't know. And then there's this stuff about design elements. Capacitors. You can place capacitors under a wire on the metal layer. Signals flow through the metal above, rate of 1 capacitor per cycle. Time barriers. Discharging. When signals turn off, wires turning will lose power instantly, regardless of how many capacitors were placed underneath. Okay. Capacitors are placed on the silicon layer but can't be connected to it or to each other. They're only connected... Wait. So how do you connect them to anything? Okay, so I guess they don't connect to the metal layer. They sit below it on the silicon layer and affect the metal above them. Okay, well, we don't need to use capacitors yet. First, we just need... give me metal. Okay, I guess there's a WAS kind of control. No. Quer. Okay. So give me metal from in A to out A. Simple enough. Oh, that's not where I want to go. So at this point, I can create a via here. Oh, first I have to put down the silicon, I guess. And then put in 2 vias. So that seems right to me. I don't know if silicon is more expensive or cheaper than metal. Look at this. It's got a cute little diagram. Anyway, so if I hit play, I don't really understand what's happening. Oh, is this step? Yeah, okay. So it's testing me now. It's okay. We're going through this one click at a time. So whatever combinations of positive voltage in and out are being given, I'm meeting the specifications. Ta-da! Design size in square micrometers. I told you I got started in sales at Sawayama and also spent some time in marketing. I did enjoy my work, but after a while I wanted to try out something new. I'd always been a tinkerer of sorts, and the idea of working on the engineering side was starting to appeal to me. Instead of only selling the machines, I could contribute to their design. Problem was, I really had no idea where to start. Luckily, during my time in Japan, I'd made another friend who worked in engineering at a small firm that was owned by Sawayama. His name was Daisuke Dan Iwashiro. I think it's Daisuke is how you're supposed to say it. I don't know. I'm not very familiar with Japanese. So, what the heck? Design size. Is that the only thing we're being measured on? And how did you manage to take up 30? I don't know. It's a mystery. Put down a lot of excess metal? Question mark? Okay, how do I leave? Design browser? Yes. Build an AND gate. Out X should be high when in A and in B are both high. Yes, so we learned about transistors in the instructions. I remember blue blocks transmissions and red lets them through, right? So we want the controller on our thing to be red, which means we want the main carrying line to be blue. So there's some metal. I don't know aesthetically like what I should do here. But this seems fine. So I think that's how you build this transistor, right? Okay, it looks good. So the blue transistor carried the signal from this, and the red one let it through only if the red one was also high. So that's fine. Okay. You'll need to create a transistor for each input, so the signals do not interfere. What? If you, how do I? So we have this positive voltage line, right? So I think what I'm supposed to do, I don't really know. How do you stop feedback? Because, okay, here's the basic idea I have in mind, and I'm imagining there are going to be problems with it. So here's our in, right? And we want to make a... Yes. We want like a blue transistor here so that we can have a red one from this that'll block it. No, that'll let it through if this is high. So if this is high, we'll send a yes over here, right? Great. But if this one is high, we should also send a yes over there. So it seems like maybe we could just do kind of the same thing. Where we, oh no, that shouldn't be there. Hang on, go back. Where we create a blue silicon line to up there with a red one interrupting it. And connect this to the red one. Right? But I don't know what's going to happen when we're like, let's say in A is high and in B is low. We're going to be sending this high current over this wire, but in B will be low, so this is going to block flow between them. So we won't be sending high to another high or something like that. What if they're both high? Is that okay? Then we'll be sending high along this wire. Or sending, I don't know what the right word for that is. Sending current, sending power, sending, I don't know. And this one will also be sending, so like these two voltage pluses will be connected to each other. But I guess that's okay. They'll both drive a high current. And in the end, you'll get high at out, right? Yeah, looks good. So, what am I doing that's so bad? I guess I could probably reuse this voltage plus, right? And then not have to route everything so far over there. So, for example, I could let this voltage plus carry on here. Yes. Put in, no, hang on. That shouldn't go there. Put in the blue silicon. No, hang on. I carried the wrong thing over. I was supposed to carry voltage plus. So carry voltage plus over here. But leave a gap. Here, I guess. To run this blue silicon with another red thing blocking it. And vias. So that, I think, is kind of the same thing. And avoids this weird kind of working with both voltage pluses, both power sources. Interesting. Still worse than the mode, I guess. Probably about the median. Oh, well, sure. There's a tiny improvement at least. We could just connect these two instead of having another thing here. Is that the difference? Probably not. No. It's still the same design size, so it just cares how many spaces you used, huh? I mean, I'm not too bothered about not topping the leaderboards or anything, usually. But this seems simple enough that, like, what could I do differently? I mean, for example, I could pick this part up and move it a bit higher, so take up these 3 spaces instead. That seems bad. Because I would be not using this space, but I would be using these 2, so that would be... Oh, also, it says 12. Is that exactly the number of spaces I'm using for? Well, 6, 9... Seems like I'm using more than 12, doesn't it? How is this measured? 3x4. Oh, is it only charging me for transistors and not for metal? Huh. Well, how can you do any better than this, though, for transistors? Weird. I don't know. Figure it out later, if ever. Not gate. Okay, so that's just using the other kind of thing. That's no problem. So here's our input. And this is what's going to eventually be sent out, I guess. And that's where they're going to cross. Right, so we're letting positive voltage in only when this one is low, I believe. Yep, no problem there. Power on, reset. Reset should be high for the first 10 cycles after power becomes available. Okay, could you explain that further? Oh, there you go. All right. So it's going to send power to this, and I should immediately send that power to out, but have a way to interrupt it after 10 cycles have gone by. I see. All right, that doesn't seem too bad. Look at that. We don't even have any inputs. So let's just send it straight out there. And I need 10 capacitors? Is that right? I don't know. Maybe I shouldn't do such a straight line. Let's just have this for now. So we also need, well, I was going to say we need another source of voltage, but we don't. This one would be just as good, wouldn't it? So let's create a delay that's like just this long and see how long that actually goes for. Obviously right now there's no delay because I haven't put down any capacitors. Well, if I put 3 capacitors there, that's going to take it 3 ticks to charge up. Is that correct? Or is it some other number? Yeah, they charge at 1 tick each. So this is the right idea, but we did 3 instead of 10. Okay. Well, there's certainly space down here for that. I can't like drag stuff. I'm gonna have to delete this whole thing. Oh my god. So on the metal layer, please reach like that far. Because I want 4, 7, 8, 9. I need 10 capacitors, huh? So it turns out we have to route like this or something. And we want the main path to be red so that the blue can block it with vias here. Is that right? Yep. Was there some better layout I missed? There must be, obviously. It feels very awkward to have to go up here. I don't know exactly why. Oh, I see. No, go back. I think I see. What I should have done was interrupted here, yeah? Well, that's not any better. Hang on, what am I actually being charged for in the score? 5x4, it says. Okay, that's the space of all this stuff, I guess, right? Not including this little bit of metal. So capacitor is the smallest footprint to fit your transistors into, I guess. Okay. So I guess if you wanted to improve your score, you would have these 10 transistors take up like a 4x3 area instead. Obviously also not all of it. So that's 4x3, for example. Although it seems perverse, why not? Go like that or something? I don't know. This doesn't seem like it's improving things. Huh. All right. Well, let's get back to the... How do I do that? View registration. Chipwizard. License number 1. Amazing. Oh no, there's 2 new ones. I don't know if I can finish one in a reasonable amount of time. Let's have a look. Out should be high when any of the 4 inputs, these 4, are high. So I mean, we built an OR gate already. In principle, we just want 4 of those. 3? 3. Is there something smarter to do? It doesn't seem totally easy. Right, we want... We kind of want there to be 4 paths from voltage to out. God, this is so cramped. Are you kidding me? And each of them needs to be blocked by a single... by one of the 4 inputs. I don't know how you're supposed to do that in this tiny little space. You know, for example, this could be one path out if we did like that, for example. But fitting 3 more copies of this seems unbelievably hard. Let's see. I mean, maybe it's not that bad, but I think it is. I mean, I guess one more is no problem. If we can, you know, for example, do that. And I guess it's not too hard to squeeze in one more. Like that. If I have... you know, that. But how do I squeeze this guy in? Obviously, I haven't put in any of the vias, but they just go in the obvious places. I'm aware there's a lot of space I'm using very inefficiently, but I'm not sure how I was supposed to use it better. Like, I need a straight line of blue silicon to be interrupted by a line of red silicon from here, and there's no place left to put straight lines. Is there? I mean, sure, you could run one like this, but this thing can't get here to block it, I don't think. So, what the heck? Maybe the problem is how I routed this one in. It looks appealing, but it takes up a whole column, right? This almost looks like a Tetris problem, doesn't it? You have to sneak in, or like a tetromino packing puzzle or whatever. You have to get this T shape in here 4 times. It's obvious they can't all go along the middle. Let's just try drawing it out like with metal for now, as like, and see how many of these are actually, you know, legal packings. Like, here's a cool idea, right? That doesn't take up much space. And then we could try doing that again here, for example. Now, of course, we don't actually want this to be metal. Is it even possible to route stuff to there? Let's say we actually drew all of these. Like that. Now we have to get metal from voltage in to pass over like that, I guess, right? And then V0, or this input 0, can go that way. This can connect here, this connects here, and this can connect either as metal or silicon, it doesn't really matter. Oh, this is the out. Whoops. Oh, that's why this is a bit trickier. Right. Sorry, we don't want that to connect. This is the out. Yes, I see. So how do you get the two inputs to reach over here? It seems horrible, right? Or an input to reach here. This input can go there, that's fine. Oh, maybe I wasn't supposed to do it that way, though. Because this would be okay. No problem there. And then don't do this. And then this one's easy, and this one's easy. The question is, how do you get something here? I guess you could use metal this way, right? Because there's nothing interesting happening along here. So you use the metal layer to route over top of some useless silicon. And then these things all connect out as well. I see. I think this is working. Put a via there and there, but not here. And here. Vias for voltage in here, voltage out here. This is a via for this guy, and this is a via for coming down here, right? Wait, something's wrong. These two accidentally got connected. That shouldn't be a via. This is already connected up. So is that correct? Oh, look how smart I am. Very expensive design, I guess, but also pretty normal. Don loved to explain things. He taught me a lot about integrated circuit design over beers late at night when we'd meet up after work. Sometimes at a bar, sometimes at his house where he had some equipment set up. Fun times. But it was tough to make progress, partly because the work was all theoretical, pen and paper, or in my head. I needed experience, but the design lab manager at Sawayama wasn't about to let in some foreigner who didn't know what he was doing to play around with their machines. So what was a guy like me to do? Yeah, this is a mess. And yet it feels like a fairly natural solution to this, as long as you sit down and realize there is a solution. And I think I, arrived at it by a meaningful and useful series of steps. I didn't just stumble into it. Thinking about the Tetris pieces, figuring out how to route everything. I don't know, I'm happy with this solution. So I'm being charged for 6 by 5. That's the entire area, because there's not a single row or column I have no silicon in. I don't see how I could change that without radically redesigning everything. Okay, well, that's all for today. Hope you guys enjoyed. Thanks for watching, and I'll see you next time.